Hi, Anthony Carruthers, Better Lesson Master Teacher Project. And here we are proving case 2 of the inscribed angle theorem. So in this case, the center of the circle is actually in the interior of the angle. And while it's probably not going to be obvious to students how this relates to case 1, um, that will hopefully become apparent when we add some auxiliary segments. So again, auxiliary segments are an overarching theme in this lesson and actually in this unit. So the segments I'm going to introduce are segment AO and also segment OC. And then I'll want a segment that goes from B through O and lands on the circle. So to do that, I'm going to start with a ray that goes from B and passes through O. Okay, and then I can take the part of that ray that actually intersects with the circle. So like that. And now I can hide the ray itself. Okay, so I will give students a second to see how this relates to case 1 and have them talk that up. And hopefully some of them would see it, most likely all of them, or not all of them would see it. So I would go ahead and just make it a little bit more clear by calling this angle 1 and calling this angle 2. And then we would talk about how basically we have a combination of 2 cases of case 1. So we know that using the proof that we've already established for case 1, that we could show that the measure of angle 1 is half the measure of arc AG. Okay, and then we could also show, using the proof that we did for case 1, that measure of angle 2 is half the measure of arc GC. So at that point, I would leave it up to students to figure out how they would do the rest of the proof. Basically, they would be using arc addition postulate, some angle addition postulate, but they have the basic things they would need in order to complete the proof.